Vom începe acum cu a treia secțiune a zilei de astăzi. Se spune că tehnologia are puterea de a schimba lumea, iar eu zic că următorii vorbitori au puterea de a schimba atmosfera aici, prin pasiunea pe care o vor avea vorbindu-ne despre cariera lor. Următorul vorbitor este Sergiu Adrian Fatol, software architect și senior developer la Arobs Transilvania, full stack developer axat pe availability, performance and security, pasionat de machine learning și arhitectură. Îl invităm alături de noi pe Sergiu Fatol.
Hi everyone. So, because we have an audience who is not speaking or not understanding Romanian, I will have this presentation in English. I hope this is okay. My English is not so fluent in some moments when I'm trying to find my words, but I will take some time and think about it. So I'm sorry about that. So what I am going to talk today about is a very fascinating programming language that I like a lot. Firstly, thank you for my introduction. It was very nice. So this programming language has started at Google a few years ago, maybe 12 years. And I will try to clarify why this language is so important for everyone, why it's so performant. And by the way, you see this small hamster here, or mouse. This is a gopher. This is the Go programming language mascot, and you will see it a lot in my slides. I want to give credit to Ashley McNamara, who drew these pictures and made them available on GitHub. They are Creative Commons license, so we can use them. So let's talk about the general overview. What is Golang? Golang is an open source language. As I said, it started at Google in 2007. It was designed in-house by three very known scientists or researchers who worked previously in open source on Unix and Java, very famous projects. In 2009, this language was made open source for everyone, so we can use it as we want. It's nice because it's very easy to build the programs with it. It's very simple, it's reliable, and it's designed directly for the web. Let's go in more details. Let's see some technical aspects of this programming language. So I think the most important parts that we want to talk about are these characteristics here. So Golang is a statically typed programming language. If you don't know what statically typed means, think about it. Every time you pass a parameter to a routine or to a function, you pass an argument. The function needs to know what kind of object or argument it will receive. The function needs to make sure that the operations that are done in the algorithm are done correctly using the same objects again and again. If the functions receive a wrong parameter of a wrong type, this means that unexpected results can occur. So for this, we have to make sure that the parameters are verified during the runtime of the program. So this can be done in two ways. By using static typing at the compile type, the compiler of the program, the language, will make sure that all the parameters have the same time during the execution. There are dynamically typed languages that will make sure that the parameters have the correct types during the runtime. This makes the programming language a little bit slower. It has to make sure that the checking routines are executed during the execution. So this is why Go is faster a little bit, and the executables or the binary code, the binary executables resulted after the compilation are very small, much smaller than a dynamically typed language. Do you know any statically typed language? I will help you. C, Java, yeah. C Sharp and Java, C++. Do you know dynamically typed languages? Yeah, JavaScript, Python, PHP. Usually the scripting languages, how we call them. Go is a compiled language, meaning that the results of the compilation is binary. It's a machine code or a native code that can be understood by the processor. This transformation in machine code can be done in two ways. During the compilation, so after we write the code, we compile and we get the results, or during the execution. These programming languages that do this during the execution are called interpreted languages. And every time they run, they have to change, to interpret each line and transform it to machine code. Do you know any compiled language? Again, C, Java, C Sharp, C++. Java and C Sharp are a little bit different because they compile to bytecode. The bytecode is run in a virtual machine that is available on many platforms, but you have to compile only once for programming language. So you compile once in this bytecode, it can run everywhere. But Go and C++, you have to compile them specifically for each architecture. So when you compile and you get the machine code or the native code, this will run only on the architecture that you compile it for. So compiling a program will make it faster also, a little bit. In the recent times, the interpreted languages have made progress, and they are faster because they can cache the bytecode resulted after compilation, but still, compiled it's a little bit, let's say, a few percent faster. Memory safety. Memory safety is incorporated in Go by default, so it's really hard to access memories, locations that you are not allowed to, and you don't have to manage it manually. Or the programming language takes care of this pretty easy. There are languages that do not give you this feature, like C or C++, and you have to handle it every time. When you allocate a new object, you have to free the memory and so on. You need to use libraries in order to help you. But this feature is by default available in Go. Another cool thing about Go is the garbage collection. It's incorporated by default. I will have a slide later where we will go into more details. And concurrency, which is I think the big thing about it. So before going into more details and see why Go is so cool, let's see some critics. Some guys made a website, repository on GitHub. Go is not good, where they collected every article from the web they found, and they found that the most complaining parts are these ones. People say that Go is too simple, so Go is making them feel stupid because they don't have to think too much about how to make it. It lacks syntactic sugar. I will give you some example later and show you why is that simple. Go has no generics. Generics are, for example, when you have a method that can do some generic stuff like ordering or sorting stuff. So you can implement one algorithm that can do the same thing for many types of objects. You can order many types of objects using the same algorithm. You would prefer to use a generic function for them. So you implement a generic function that can receive as a parameter different type of objects. This is not supported in Go by default, and this decision is made by the scientists or by the researchers that created this language consciously. So it's not a thing they forgot to implement. They wanted to keep it more simple. The error handling, people don't like this. There are no exceptions in Go. You only can have errors, panic. I don't know. Do you have any experience with Go? Anyone? So yeah, you cannot throw exception. You can panic in Go. If you go to the Go website, you can actually see some examples and run the code in the page, and you see how nice it is. So some people complain that there are no unused variables or imports. So every time you declare a new variable in Go, you have to use it. Otherwise, the compiler will complain about this. Many people don't like it because they want to make quick prototyping like you do in Python or other languages. In JavaScript, you can declare some variables, don't use them, and later maybe you delete the program, and it's not a problem. In Go, you have to do this perfectly. Like you import a package, you have to use that package. Otherwise, you consume resources. You make the code unreadable. So many people complain about the lack of OOP, object-oriented paradigms in Go. Go has OOP, but it's its own way. So it's not the classical class definitions and so on. And they don't like the semicolons and the line ending. Like you can do this in Python, but you can do this also in JavaScript if you really want. Yeah, so these are some critiques. Let's go into the good stuff now. But before that, let's see a little bit of history. Go is an answer to the problems that Google had in the early 2000s, 2005, something like that, when the multi-core processor started to appear and to develop. They were using more widely on the server side. The network systems were, massive computation clusters were created. The web was defined. Before the 2000, the web was only invented, but now it was widely used. When you say Google, I think you can say this is a synonym with web. I think many people think like that. Also, think about that the servers at Google had programs that were as big as millions of lines of code. There were hundreds or thousands of engineers working on these millions of lines of code every day, committing code and changing the code a couple of times or more times a day. And the build times were getting higher and higher. So in the beginning you had a few minutes for building one server, but then you get to hours. This was a problem. Google tried to create this this language, in order to fix these issues. They need these characteristics, so these important characteristics to be present in the design of the language from the start. And we will talk about each other. So first, we will talk about concurrency, the distributed systems, how problem of present on many machines, garbage collection, and readability of the code. Do you know the SIG10K problem? It's a very famous issue in the beginning of the 2000s. The SIG10K problem is actually a challenge to support 10,000 connections concurrently on a server. This was a big deal in the early 2000s. In order to solve this, many researchers and open source community started to implement asynchronous input-output, event queues, loops. The most famous are KQ and EPOL. KQ, I think, is on BSD, and EPOL, I think it's on Linux. These libraries were trying to solve the concurrency issues. Before that, each server managed one connection by creating a thread for it. This was okay, but the resources were limited. So think about every time you have a new connection, you have to create a new thread. If one thread has 1 or 4 megabytes, you would quickly get for 1,000 connection about 4 gigabytes of memory. This was not possible. So using event loops was more efficient, and Nginx tried to solve this. It was very good at managing all these connections simultaneously. The performance was great. The problem is that the business logic, you could not write it in Nginx. So you had to connect it to another type of software that was, for example, written in Ruby, where again, when you get to the concurrency, you have the previous issues again. So Node.js actually solves this problem. It uses at the base an event loop. The language is JavaScript, and I think this is why this language got off so well and is so well known. Not because the 10K problem. It's because the language behind it. Go thought about this differently. So they wanted to have the best solution and looked into the future, and they said, we think green threads are the real solution. Green threads are something in between event loops and threads. These are not managed by the kernel, by the operating systems, because the basic thread, the threads that everyone knows are managed by the kernel, and these are slow. Every time you create a new thread, you have to allocate and manage these resources, this memory that the threads have to communicate one with each other. Green threads are much faster. They don't use the heap to allocate the memory, they use the stack. And that's why Go created the Go routines. Go routines, I would say, they are the first-class citizens in Go. This is an example of how to use a Go routine. Just a short introduction. The first line is defining the main packages like in C. Go is very similar to C. They thought, let's take C and make it better. And simple. And so then you import a package that's named FMT format. We use this to print something. You declare a function, F. The N is an integer. We use it just to mark the function we are in. I will show you later. So this is a function that makes a loop from 0 to 10. Easy. Then the main code, the main function starts. And we have this special word, go. Go is the mark that we are going to call this function concurrently. So we are starting a Go routine here. The first Go routine in Go is the main function. Every time Go starts to run, the main function is run as a Go routine. Then we call F with the argument 20, and then F with the argument 30. These three functions, main, F with 20, and F with 30, we run in a concurrent way. What would happen if we would not have the last lines? The program will stop, because main will execute immediately. But we have the last lines in order to keep the program waiting the user's input, so these two methods will run concurrently. The results of the functions will be printed on the screen, but you will not see the synchronous output, like 1, 2, 3, 4, 5. You will see a random printing from the both functions. So from the first function, you see 1, 2, maybe from the second one, 3, 1, 2 also, then from the next one, and this is randomly. And this is very, very easy to run, to have concurrent methods in Go. In order to communicate between these two functions, you can use channels, which is very nicely implemented with Go also. If you think about C++, I think you have to use semaphores or something like that. I don't remember. It's quite difficult to do concurrency in C and other languages also. I will not go into more details here, but I will let you find out more about this. Think about Google. When you think about Google, you think about millions of machines, millions of millions, maybe billions of machines, zillions of machines. The language is designed from the start for large software systems. So Google thought we have to make this programming language to solve slow builds, uncontrolled dependencies, because think about in millions of lines of code, you have thousands of packages that communicate and use other packages. The dependency, it's a hell here. They were using C++, Java, Python. Programs were hard to read by new developers. New developers were coming all the time. So they wanted to have something that is easy to read by new ones. Cost of updating some server was very high. It was difficult to write or to decide what tools to use. So they wanted to have something directly incorporated in the language. And cross-language build, I will not go into these details, but Go can be inserted in some other languages. So this is a design decision they made. So, for example, they could decide Go in Python's way. You can keep indentations to specify that a new block is starting. But they say, okay, if we copy Go in a Python language and execute it with some embedding or whatever, this will break, Python will break Go syntax in the other way. So another important decision is Go does not need any runtime pre-setup, let's say. It doesn't have dependency on the system's libraries. So when you compile a Go program, you will, by default, you will have all the dependency compiled with it. So you don't have to link other libraries. For the ones that don't know what garbage collections mean in programming language, it's about collecting the memory that objects that are not used anymore occupy. And many programming languages have this, like Java. This has some negative sides, like it adds a general overhead, it adds some latency, and the implementation of the garbage collection is quite difficult to do. But Go has this by default, so this implementation is done already, you don't have to think about it so much. In a concurrency world, managing the memory is very difficult. You allocate some memory in one routine, you can exit it in another routine and so on. Doing the freeing of memory manually every time is very hard. That's why they decided, yes, there are negative parts of garbage collection, but we have to do it because we improve the readability of the code. the implementation of the garbage collector is a little bit different because of how the objects live in the memory. So in Java, you have a second level of indirection, meaning if you declare an object, a class that has some type, you have another object of another type. The memory allocation is done by making a reference to another place in the memory. But in Go, there are no this kind of classes or types. Go is very much based on structures. The structures, when you allocate a new structure, you will have the types in the structure allocated in the same block of memory. So the garbage collection can very quickly deallocate that part. It's much efficient, I think 1 order of magnitude more efficient than in Java. If you know the internals of how the garbage collection work in Go, you can improve your coding styles. You know how to define the objects and the structures, the types. So you can eliminate this pressure on the garbage collector and don't give it a lot of work to do. Okay, and the last very important feature that make Go modern language, 21st century language, I think is Cuadrilla Readability. In 2007, Google had about 17,000 employees. In 10 years, they had 76,000, a lot. The code base was growing millions of lines every month. Think about if they would do this in Java, include polymorphism or another language, metaprogramming. You have to be very, very smart to debug this. It's very difficult to find 76,000 of very smart people. You can see this, I think. So they thought the code has to be readable by new engineers, by freshmen, by people who are hired to find solutions, not to write lines of code. This was, I think, the most important principle. And they thought, in order to fix this, simple is better. What I mean by simple is better, there is no while in Go. You can do this by using a for loop. A for loop in any other language has usually 3 sections. You declare a new variable, you compare it with something, and then you increment or modify somehow. What if you could use a for loop, but only have the condition part? This will simplify the language. You don't have to make new paradigms and so on, and it works in the same way. Ternary operations are not supported, or one-liners, how they are called. For example, in PHP, you could do something like if, then else, and replace it with the condition, question mark, do something, an operation, dot, dot, and another operation. This is not supported in Go because it breaks the readability. If, then else is the standard. They even think about removing the else part. This is, it's strange, it's a bit that. But if you can think about it, every time you write if then else, you can refactor this. Just try it. Try it for a few days. Try to think about how to remove the else part. You will see this is possible. I did this test. Okay, maybe they will not remove the else part, but they think about it. Let's see some cool projects that are built with Go until now. Go is used by Google, I think in most of the projects. It started to being used at a lot of startups. I think they use it already in some parts at Facebook, at Yahoo, and a lot of big companies. It's catching up with the other languages. It grows, it has a high growth rate. And these are 2 of the most known projects built on Go. It's Docker containers. Do you know about Docker containers? A faster way to, let's say, virtualize things. and they are. You can, for example, you can think about it having many computers on one computer with many operating systems, but Docker is built using Linux. Let's keep it that way. Okay. And Kubernetes. Do you know about Kubernetes? Nice. Kubernetes is a container management framework. So it's very flexible. If you really want, you could build the Google Cloud using Kubernetes. It has managements to scale up with the container, so you can have a container that runs a service. You can specify the number of services that you want to run, and it automatically creates new services. It can replace a service when one dies, some error happens. It can do a lot of stuff. It has role-based accessibility. You can manage that. The downside is that it's hard to configure, but if you really have the time and you are passionate about this, you can use it. Let's see some conclusions. Go may sound dull and industrial, but its focus is on clarity, simplicity, and composability. These are from the design incorporated in the language. They wanted to have clear dependencies, clear syntax, and clear semantics. They prefer composition over inheritance. We can talk about after this talk about this part. And the simplicity is provided by the programming model. They try to make the code more readable and more simple by getting this pressure of the programming, the pressure of clearing memory, to think about how to concurrently communicate and how to improve concurrency by incorporating this into the programming. And it comes with a lot of tools. When you download and install Go, you have the tools there by default. You have tools to debug, to watch the memory, to see if you have some routines that are going off the limits with the memory. You have a Go formatter. Go FMT is the tool that formats the code, so you then don't have to have these discussions with your colleagues. I think we should use that standard or that standard. There is only one standard. And last thing, I think that is very important. Go is built by engineers for engineers. That's my conclusion. Before ending, I want to give some credit. So my presentation was based on Carmen Ando, The Why of Go. You can find this presentation on Google. I recommend you to see it. It's very nice. Ashley McNamara, who drew these beautiful gophers you've seen on all the slides. Rob Pike has a very nice blog post or article, Go at Google, language design in the service of software engineering. Rob Pike is one of the creators of Go. I forgot the names of the other two, but they are very well known also. Credits to Google for making this nice language, wonderful language, and credits to Wikipedia for all the documentation. And that's it. Thank you. If you have questions. Yes, please.
But you have also structures to manage the concurrency, like semaphores, await.
Yeah. You have channels. There is a, I don't know how to explain. You can pass messaging in between the routines, yes, using channels. I don't have an example in the presentation, but you can define a channel and then you can read the channel in one routine and you can read the same channel in another routine, push the messages in between. This is.
So if you have a concurrent resource that you want to access from different coroutines, you have to use the messages? How do you
You use the channels.
Okay.
where you pass the messages in between the routines. I don't want to explain it in very detail, but I know they are safe to use. You can even pass pointers through them.
Okay.
But I don't know the technical details of the implementation. Okay? Well, thank you very much. I hope you will test Go very soon. Go on their website.